Our last parts to review some of the functions are trigonometric and then circles, and I think you guys should have enough information to graph these functions. Okay, so we do have 6, and I'm going to explain them now. So let's do sine of x first. Notice your x values are in radians, and so let's get down to business a little bit, even though I've already plotted it. Let's just plug that in. So I think I've been inputting for your x values every pi over 2, and so we start off with 0. Sine of 0 is going to be 0, okay? And then pi over 2, or 90 degrees. So sine of 90 degrees, or sine of pi over 2 is going to be 1. Okay. Then, you know, sine and cosine, 35 and 37, are oscillating functions, so they're going to keep going back up and down, up and down. So when we plug in pi, 180 degrees, sine of pi is going to go back to 0. 3 pi over 2, sine of 3 pi over 2, or 270 degrees, is going to be -1. And then the oscillation, the period for this is every 2 pi, so it just goes back up to 0, or 360 degrees for 2 pi. So sine of 2 pi is going to equal to 0. So you have an oscillating functions. It goes from 0, 1, 0, -1, 0, and just goes up and down like that. Okay, so from there, I mean, you can do your shiftments and then also your patterns, you know. So you move pi halves to the right, 1 up. And then pi, I don't know, I usually don't really do arrows so much over here just because they're oscillating, but you guys can do this if you want, okay? You know, then you move pi to the right and you go back down to 0. 3 pi over 2, the next one, -1, and then 180 degrees is 0. Okay, so let's go and graph that on an example. I think I should have one, 56. Good, so 56. Even though we are in radian modes here, we are still going to apply the same type of shifting at our starting point. Our starting point, remember, opposite of what you see, and then same. So we're going to start at -pi, 1. So let's start over there, -pi, 1. Okay. And then we're going to follow our sine of x pattern. Sorry, I don't particularly know the number for this one. Number 35. Okay. So from the starting point, pi over 2 to the right, 1 up, pi, 0, 3 pi over 2, 1 down, 2 pi back to 0. So every pi over 2, there's some sort of movement, okay? But we're going to go every step of the way. So every pi over 2 is just going to be on these marks over here. So start from the starting point, you're going to go pi over 2, and then you're going to go 1 up. Go back to the starting point, then you go pi, and then back to 0, so right over here. So no movement. Then you go 3 pi over 2, which is this part over here. Then you go 1 down from the starting point, go back to your starting point, then go 2 pi. So 1, 2, 3, 4, and that's 2 pi still the length. And then back to 0 like that. So it should be oscillating, and then we can finish the graph like that. Just making sure that you have arrows like this. Okay, so that should be okay for now. All right. Other graphs that we have to mention are cosine. Cosine and tangent, but in just in a little bit. There's a reason why I put 35 together along with 36, because one easier way to get the cosecant graph is based on the sine graph. Okay, so this is cosecant of x, and this is your sine of x over here. cosecant, I do want to remind you guys that it is not an inverse, it is a reciprocal. It's a reciprocal of 1 over sine. Okay, so to get this graph, it's actually based on the sine, not based on the sine graph, but we can use a sine graph, and I'll show you what it means. So I'm going to just draw the sine graph over here. Okay, so the little green is sine of x. And when we draw in the sine graph in with the cosecant, then we see some cool things. Okay. Okay, so the cool thing is that on these hills and valleys, so the hills and valleys right over here, that's your starting points for your cosecant. Okay, so over here, 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 and here. They're also oscillating in a sense that you know, we have like some face-up functions and face-down functions as well. And I'm going to go get some sort of straight edge because we can add some asymptotes or boundaries to this. Okay, so we do have some asymptotes. Asymptotes are every pi. Okay. So this is not for the sine graph, this is for the cosecant. Okay, so in a sense, I'm really not teaching you like some sort of pattern, but really how to just grab the cosecant graph. Use the sine graph and the maximums, the highest and the lowest values of your sine graph, use that as your lowest point and highest points for your cosecant. So we're going to make an asymptote over here, and then since over here sine of pi over 2 is 1, that's going to be our lowest point for this portion. You just kind of make a graph like that. Okay, then asymptote, then go down to the -1, and then you're going to make another like kind of almost parabolic shape over here. And 2 pi over 2, make another, 2 pi, and then you're going to make another graph starting from over here, from the highest point of sine of x, and then just use that u. Okay, all right. Cosecant and secant are pretty similar in the aspect of sine and cosecant. So let's do number 37, cosine of x. Oh, sorry, and then we got that e over here. So this time around, I'm still plugging in the same numbers, 0 pi over 2, pi, 3 pi over 2, and then 2 pi. Okay, so 90 degrees, 180, 270 degrees, and then back to 360 degrees. Okay, so if you notice, cosine of 0 is equal to 1. So it starts with 1 over here. Cosine of 90 degrees, or pi over 2, goes to 0. Cosine of pi is going to be -1. Cosine of 3 pi over 2 is going to be 0. Cosine of 2 pi goes back to 1. So it's oscillating, but we have a different start. It's going to start at 1. Okay, so 1, 0, -1, 0, 1. Okay. We're going to use the cosine function to develop our secant function, which has already been drawn. And so in the same respect, I'm going to draw the cosine of x graph in 38. Right over here. Okay, so this is our cosine. Very similar to the cosecant. Your secant function, secant is spelled like this, secant of x. Okay, we are going to have some asymptotes, and then our asymptotes are at every pi over 2. So there's a shift. Okay, so this is pi over 2, and over here is 3 pi over 2. Okay. And over here is -pi over 2. negative 3 pi over 2. Okay, so use the cosine graph to your advantage to draw the secant. And I do want to remind you guys that secant is the inverse. I mean, sorry, not the inverse, it's reciprocal. 1 over cosine. Okay. So the highest point of cosine at the 0 is 1, and then you're going to make that shape. You would start making the asymptotes over here at every pi over 2. Once that's done, go ahead and start from pi negative 1, pi comma negative 1, and then make that kind of almost parabolic shape. Make an asymptote, and then after that, 2 pi comma 1 will kind of be like your lowest point, and so on. Okay. Asymptotes. Every pi over 2. Alright, we got 2 more to go for tangent and cotangent. Our tangent and cotangent graph will kind of look like snake graphs, really. And they also have their asymptotes. So cosecant, secant, tangent, and cotangent, 36, 38, 39, and 40 will be having asymptotes barriers. This too will have asymptotes at every pi over 2. So I'm just going to draw that. Notice that I'm not really teaching patterns too much because it might be a little bit hard to teach with the arrows. So asymptotes at every pi over 2. Okay. When we do tangent of 0, it is 0. Okay. One reason for that is when we do tangent, here is one reason. Tangent, remember, is sine over cosine. Okay? And we can graph some of the values from the tables that we've done. On 35, sine of 0 is 0. Cosine of 0 is 1. So 0 divided by 1 is 0. So you can think of this as how we're going to get all the tangent values. Okay? So there's a point in time where if we try to do pi over 2, we can't do it, and that's why it's an asymptote. Well, the reason for that is, well, take a look at your denominator. What is cosine of pi over 2? Let's go take a look. Well, cosine of pi over 2 is 0, and we cannot divide by 0. And hence that's the reason why we have that asymptote. And it's also going to be the same reasons why these are asymptotes as well, because if we plug in these numbers here, so say for example, pi over 2, and we put cosine of pi over 2 over here, remember cosine of pi over 2 is 0, 1 divided by 0, we can't do it. And so that's why we have asymptotes, okay? We can't divide by 0, we're going to put those asymptotes there. Same thing for the sine x as well. If we did sine of pi is 0, we can't divide by 0, we got that asymptote. Okay. The way that I've tried to remember is tangent, it goes from bottom left, it's just going to go increasing, and it's an increasing. So it's an increasing function from negative pi over 2 to pi over 2. So it kind of has like a, it almost kind of looks like a cubic function if you really want to think of it this way. So you see that cubic function like this, and that's the way I have thought about it, like that. As opposed to now your cotangent. Okay, so let me just write it out. Tangent of x. And then cotangent of x. Cotangent of x is going to be 1 over tangent of x. Or you can do cosine over sine of x. So anytime sine of x is 0 over here, that's the reason why we're going to have those asymptotes. So we're going to have asymptotes at every pi. So say, for example, if we were to have done pi, and we plug in pi over here, well, cosine of pi is -1, so that's okay. But if we did sine of pi is 0. Okay, and we can't divide by 0, so hence we have that over here. And so that's how we're getting these values. So if we plug in pi over 2 is 0 for the cotangent because cosine of pi over 2 is 0. Sine of pi over 2 is 1. So 0 divided by 1 is 0, hence is why it's over here. So it's going to be zeros at every pi over 2. And it's a decreasing function like this. So it's just going the opposite way of the tangent. Okay. So hopefully this is a nice small review for your trig functions and how to graph them and what they look like.